So what view do we want to take for this one? Yeah, top view. Yep. And I guess I'll do the calculation for this point. The coordinate system looks like this. The centripetal acceleration vector points from here toward the center. And we know the magnitude of that because we know the speed and the radius. So we have 2 squared over 2, so 2 meters per second squared. And then the free body diagram, I'll do that on the next page. Okay, free body diagram. This is like a top view, you know, so that's like the back of his head, his shoulders, his knees. So what forces are acting? There's the weight, but that's going into the page. There's a normal force that's coming out of the page. And then the only thing left is that horizontal force that we're trying to calculate. We don't know the direction of that force, so I'm just going to call it F. By the way, what's providing that force? What? Yeah, it could be if he was hanging on. Otherwise, that would be friction. We haven't had to think about friction as a full vector because we've always known the direction before. But in this case, we don't know going into it what the direction of that friction force is going to be. So I'm just going to write it as an unknown force vector. So Newton's second law says Fx, Fy is equal to the mass, 15, times the acceleration, 0, 2. And so that force vector is equal to 0, 30 newtons. So the entire friction force required to keep him from sliding off is just pointing towards the center of the carousel. Basically, it's the force that's required to keep him turning instead of, if all of a sudden all friction disappeared, what he would do from this point is just shoot off the side in this direction, the direction he was going. That friction force is required to keep turning him left, you know, keep moving around that circle. Any questions about that one? Yeah, there's no handles on this carousel. No, he's very dumb. Yeah. Yeah, he's just sitting there like the picture. I drew you a picture. Look where his hands are. It does look like, but no, his hands are in his lap. He's petrified with fear. Any other questions? Because, so you choose the point you want to analyze, and then you draw the vector going from the point toward the center. And so, I mean, basically it was because I chose this point. If I would have chosen this point, it would have been in the positive x direction, and then it would have been 2, 0. Any other questions? Yeah. Well, so that would be the right answer if you were looking at the point when he was over here. But, you know, that acceleration changes. And by the way, you know, notice that, so that acceleration vector is changing depending on where he is in the circle. And that tells us that this is the first type of problem we've done in this class where acceleration isn't constant. the magnitude is constant, but so like this is the first time that we couldn't use those two-dimensional constant acceleration problems to calculate, you know, like how far he goes over a certain amount of time or something like that.
So the answer is always going to be incomplete without the picture.
Yes, although, I mean, a lot of problems will just ask you for like, what's the, like if I had asked for the magnitude of the force, the answer would always be 30 newtons. If I had asked for the magnitude of the acceleration, the answer would always be 2, no matter what point you chose. But yeah, you really can't get to the answer without drawing a picture and choosing a point. Any other questions? Okay, that's it for tonight.